In the diagram below, the points A, B, C, and D are on a circle. Angle ACB is equal to 42 degrees. Angle CAD is equal to 33 degrees. And the lines AC and BD intersect at X. BD is the diameter of the circle. Grace and peace to you, and welcome back to my channel. This is Donald C. I'm the author of Hidden Mathematical Genius Within Revealed. Today's question is on a circle, properties of the circle, or circle theorems. Okay, so before we start answering this question, let's talk about a few theorems of a circle, or angle properties of the circle. So the first property, or the first theorem which we need to know is about angles that are produced from the same arc. So let's say we have the arc AB. This is arc AB from this point to this point. So this can be an arc. An arc is just a part of a circle. So we can have an arc or a chord or a segment, this area. So what we should always remember is that angles produced from the same arc, chord or segment, are equal. So if this arc AB produce an angle there at the circumference, let's say angle X. Again, this same arc or chord produce another angle at the circumference. Let's say the angle there is Y. This same arc or chord can produce another angle on top there in the circumference. Let's say angle at Z. Okay, so what we should know is that angles produced from the same arc, chord or segment, are equal. So if this angle is A, even the angle there will be A, and the angle there will be A. Angles produced from the same arc are equal. Then the other property is about angle produced from the same arc or chord and the segment. Let's say this arc or this chord has produced an angle at the circumference and another angle at the center. So what you should remember is that angle at the center is twice an angle at the circumference. So if this angle at the circumference is A, then at the center it will be 2A. You just multiply by 2 if they are coming from the same arc, chord, or segment. Then another property is angles produced from a diameter. So if this is a circle and we have center and we have a line passing through the center from one end to the other end, then that line will be a diameter, and this diameter produce an angle. Let's say we have diameter AB. So angles produced from a diameter are 90 degrees. So if you have an angle that is produced by a diameter, just know that the angle will be 90 degrees. Okay, let's see if we can answer these questions using these three properties. So we are told find angle CBD. Find angle CBD. The angle there, CBD. So we can see that this angle CBD, that is angle at B, we can see that it is coming from a chord CD. or an arc CD. We can see that this arc CD or chord CD has produced angle at A, which is 33, and this same chord or arc has produced another angle B, which we are looking for, that is angle at B, meaning angle CBD is equal to angle CAD, which is equal to 33 degrees. These are angles produced from the same chord, arc, or segment. Okay, so we'll say A angle CBD is equal to angle CBD is equal to angle CAD. So these are angles from the same arc, angles from the same arc or chord. Therefore, angle CBD is equal to 33 degrees. We go to B. So B, angle ACD, angle ACD, angle ACD, the angle there. So here we can see that this angle ACD and this angle BCD are 42. When you add them, we should get a 90 degrees. Why? We are told that BD is a diameter of the circle. This line is a diameter. Angles produced by a diameter are 90 degrees. So this angle here, the whole of this angle should be 90 degrees because it is coming from the diameter BD. Okay, so we'll say angle ACD plus angle BCA is equal to 90 degrees. So this is an angle from a diameter. An angle from a diameter. So angles produced by a diameter are right angles. That is 90 degrees. So you say angle ACD plus BCA, that is 42 degrees. So plus 42 degrees is equal to 90 degrees. Then to remain with angle ACD, the 42 degrees will go this side. So here it is plus 42. This side it will be minus 42. So we'll say angle ACD is equal to 90 degrees minus 42 degrees. Angle ACD is equal to 90 degrees minus 42. Yes, you get that is 48. Yes, 48 degrees. So we have 48 degrees. So that is the angle there. Then C, angle AXB. Angle AXB, the angle there. Okay, there are many ways in which we can calculate this angle AXB. We can get the triangle there. Here, this one AXD, triangle AXD. It's like this. We have X there, we have A there, and D there. We have 33 degrees, and there, this angle here, we can see that this angle at D is produced by the arc AB, and this arc AB has also produced an angle at C, which is 42. So meaning even this angle should be 42. So the angle there is 42 degrees. And what we should always remember is that if you have a triangle, an exterior angle of a triangle, if this angle is D, this angle should equal to the angle here. Let's say angle there is A and angle there is B. Opposite exterior angle is equal to sum of opposite interior angles. So you just add these two. So D is equal to A plus B. Opposite exterior is equal to sum of opposite interior angles. So the angle here is equal to just the sum of 33 degrees plus 42 degrees. That is, opposite exterior is equal to a sum of opposite interior angles. That is of a triangle. Okay, so C, angle AXB, this one is just equal to, that is 33 degrees plus 42 degrees. So angle AXB is equal to 33 plus 42, you get, that is 75 degrees. So angle AXB is equal to 75 degrees. So this is how you perform calculations to do with circle theorems, applying angles produced from the same arc equal, and angles produced from a diameter right angles. That is circle theorems. Thank you so much for your time.